Hi everyone, welcome back to Surakshyaan. So let's understand how do we deal with man in the middle attack. What's happening here is there are two parties which were communicating with each other and an attacker intercepted the communication and now the communication flows to and from the attacker, right? So what do we need here? We simply need a validating mechanism, a mechanism through which each communicating parties can validate each other's identity, right? There should be a way for this user to verify if the message that has been received is indeed from this user or not, right? That is where digital certificates come into picture. A digital certificate is simply a digital identity that can be used to verify the ownership of an asset. That asset can be a server, a software, a network, a USB thumb drive, an email, a document, etc. A digital certificate uses asymmetric encryption. That means a pair of keys is generated. One is private key and second is public key. So let's say user A wants to send a digitally signed document to user B. Now, user A will generate a pair of keys. One is private key, second is public key. User A will sign that particular document using his private key. And once user B receives the digitally signed document, he can use user A's public key in order to verify the signature, or basically to verify whether the document has been signed by user A or not. So let's try to understand this with the help of a diagram. So we have user A here and user A wants to send a digitally signed document or message to user B. This is what happens on user A's side. So user A simply takes that document, passes it through a hashing function. A hashing function is simply a mathematical function as we discussed in one of the previous lectures. This hashing function outputs a hash. In world of digital certificates, we call this hash a digest. This digest is then passed through an encryption algorithm where the private key of user A is used. This encryption algorithm outputs something called signature. This signature is then packed with the original plain text document or message, and this entire thing is sent to user B. Now what happens on user B's side is user B simply first deduces the received digest. This digest, which was calculated on user A's side, is deduced by user B. How? He simply passes the received signature through this decryption algorithm, and this decryption algorithm takes the public key of user A as an input. Okay, once he passes the signature through this decryption algorithm, it outputs the received digest. So digest R stands for received digest. Now user B recalculates the digest on his side by simply taking that plain text message, passing it through the same hashing algorithm, and this hashing algorithm generates the digest. Digest C means calculated digest. Once user B has digest R, that means received digest, and digest C, which means calculated digest, he will simply check if digest R matches digest C, if the calculated digest matches the received digest. If these two hashes match, then it means that the document is indeed digitally signed by user A. And if these two hashes do not match, then it simply means the document has been tampered with. So that is how user B can simply verify the ownership of the received document. Another example is whenever your system or whenever you install a third-party software on your system identifies the developer of that application using digital certificates. So if you are a macOS user, you must have noticed a lot of times macOS prevents you from installing any third-party software, right? And it gives you a pop-up saying the developer of this application or software cannot be verified. So how does it know who the developer or who is the developer of that software? Well, it uses digital certificates. And the reason why it says that the developer cannot be verified is simply because that developer of whichever software that we're trying to install is not registered as a developer with Apple. So that's how digital certificates can be used in order to protect ourselves from man in the middle attack.